they probably use Windows. They have Windows-based systems, and they have potentially Windows-based servers as well, backing them up. Active Directory, that's one of Microsoft's best products. Almost every company needs it for their authentication. Having a solid grasp on the Windows and operations of how the systems actually work, you have something marketable with that. It'll be a lot easier for you to get co-ops, interviews, and anything with really any company on the face of the planet. And even though it's not exactly like Linux, it's the same high-level concepts will transfer over as well. So it's super important to have a base and at least one OS, regardless of whether it's Windows, Linux, or even Mac OS, if you're going the Apple route. And sort of new, right? Windows has a core version, so a non-desktop GUI version that is able to conserve some resources on the back-end virtualization platforms or the host itself to run more computationally intensive applications, which is mostly important for, let's say, cloud people, right, like AWS, GCP, and Azure, as well as if you're not ever going to RDP onto the box to configure it, like modern DevOps says you shouldn't, then the core version is perfect for that because it also conserves resources. So let's get into the structure of like how Windows kind of works on the back end. So you have these like high-level concepts is what I would call these. And they're kind of nesting. So the session is like larger than the Windows station, which is larger than the desktop, which is larger than a window. So it all kind of like pyramids in to the top, right? And so the smallest piece we have in Windows that still runs code and still has some purpose is a thread. Sessions are basically a container that houses processes and all of your windows that you see within your monitor and other objects that are in your user session from when you logged into the system. The Windows station prevents multiple sessions from communicating with one another. And it also prevents, like, say, you can technically have 2 different sessions as the same user. You can't necessarily communicate between those sessions or even those desktop environments due to the Windows station. And as you see in this diagram here, so we've got services and user mode drivers in session 0. So session 0, I think this is actually, okay. So we'll just go to this next one. We'll go down here. So one Windows station that's able to interact with the user, Windows Station 0. Others exist, but this is like the main one that we'll be concerned with. There's even multiple desktops, and you're not going to necessarily see all of them at the same time. So there's WinLogon, desktop, secure desktop, and disconnect. So secure desktop is kind of interesting, and that's mostly used for UAC. And that's pretty special because it's very difficult for, let's say, malware to hook a process that got executed in the secure desktop because it's sort of isolated at that level. It's a lot harder to just open the process that's running in the secure desktop versus if it was just in your regular user's desktop. And then obviously your desktop, which is what you see when you log in, and the logon screen, which is actually in session 0, I believe. Processes are mostly just containers for threads. So if you have just a single threaded application that you make and run it on Windows, all of the real process is doing is it's just memory allocated for your thread that Windows provisions by default. That's mostly what it's used for and like what application you ran. Now the thread under that, they're the things that actually do the heavy computation. And this is the same with most modern operating systems, like Linux is the same way. Processes are really just containers that run threads. So threads are the things that actually do the heavy lifting, do all of the work. Newer versions of Windows don't usually allow session 0 to communicate with a new session for obvious reasons. So session 0 is a privileged session, and the default for the entire system. So that's where most services run. So anything under services.exe runs in session 0. And so the important distinction to make there is that, let's say you decide to make a service because you want to do that for Red Team or something, right? And you want to pop up and you want to do some trolley thing, right? And pop up a text message or something on the user's desktop. You can't just pop up a GUI just like normal, because that'll technically pop up that box in session 0, which the user doesn't see. So you'll have to make like special considerations for that, and you may actually need a process to communicate with running in their session for you to be able to do that. And like when UAC pops up, you're actually on a different desktop, the secure desktop, like I just mentioned, which prevents like some types of malware from hooking that. Now, there are some bypasses for UAC, which just kind of remove that altogether, but for the most part, on the secure desktop, it's really hard to hook. For the main authentication system for Windows, sort of like PAM is for most Linux distributions nowadays, due to its pluggability, LSAS also has a similar level of pluggability and is used for the authentication system itself. So whether you're logging onto the system locally through the network, or if you're backed by Active Directory, at some point that all goes through the lsas.exe process. So if you're on your local system and you're trying to authenticate to your domain instead of just your local system, LSAS on your local system is actually the thing that relays that to the domain controller or the authentication body for your company, which is kind of interesting. And that's also probably Active Directory, which is backed by another LSAS on the server. So when you log in, the main way that Windows does authentication or access, so this is kind of like a weird concept that is very Windows specific, is tokens. So your user, what are you shaking your head? What? Oh, yeah, tokens are really annoying to like conceptualize, because what happens is your user gets a token when you logged in. And after that, everything you do kind of gets checked against that token. So if you create a process, that process gets created with the permissions of you. So it is given your token, and then it uses that token for everything it has to do as well. And that's kind of like a back-end thing. Even in like most Windows APIs, you won't have to really deal with the token itself. But on the back end, that actually gets checked and determines if the process has access to do that. So a good example of this is, let's say you log in as like the default administrator for your box. So when you log in, you'll get a token that on the back end it says, all right, you are the administrator. You're allowed to do these permissions, read and write to almost anything, right? You're owner. You can take ownership of whatever you want. So when you actually do that operation, like you try to write to a file in a privileged location, it's going to check your token to see if you have privileges to write to that location, because it has that in its database on the back end. And then if it doesn't, it denies you access. So that's kind of like a big abstract topic when it comes to Windows authentication and permissions, actually. The Security Account Manager, the SAM database, stores all the authentication information, and LSAS it's actually like a special registry hive, if you guys know what that is. And that gets loaded into the LSAS process space on startup of the Windows system. So two types of access tokens are a primary one. So this is one granted by LSAS. So this would be the equivalent, like you log in your box, cool. You have a primary token. Or you can actually impersonate another user. So this is kind of a special one that's not done very often. It's used sometimes with services. So if services impersonate a specific user, just for sake of example, then they just embody all the permissions that come with being that user. And there are a couple different types of impersonation that provide different levels of access as well throughout the system. So on a domain, right, LSASS actually uses the Kerberos protocol to verify user credentials. So that communication actually happens between your client box and your remote authentication server or your domain controller, really whatever is providing authentication for your corporation, your business. And it's a network level protocol, and it was developed by MIT for Project Athena. And right now, it's currently in its 5th version, which I think at this point, Microsoft has heavily modified this protocol, but the main things are still there. The main concepts of Kerberos are still maintained in their version. Give me one sec. And before this was integrated, before Kerberos was integrated into Active Directory, they actually had their own authentication system called NTLM. Yes, so NTLM is actually a protocol as well and not just a hashing algorithm, which further confuses things when you're looking at older systems, or the registry, which is basically from 1998. So, the basics, we're going to go into a basic overview of Kerberos since it's so important for modern Windows domains. So this is kind of like a flow of what actually happens as, the little duck, as the user authenticates to the system, and then what actually happens, communication between your client and your domain controller via the Kerberos protocol. So Kerberos is basically built upon tickets. Right, tickets are another abstract concept, kind of like the token that Windows uses. But basically what happens is that the client requests a ticket granting ticket from the TGS, the ticket granting service, which is running on the backend server or domain controller. This is usually, so the KDC seen here actually runs inside of the domain controller that your company would use in the sake of Active Directory. So Active Directory actually is a larger thing that uses Kerberos, because Active Directory can use a couple number of protocols as well. And so when the client gets a response, they do a ticket granting service request to the KDC. So that would be your domain controller again. And then the TGS replies and then sends back another ticket that determines what level of access you have for a service. So I like this diagram a lot better than just explaining words, because that's super annoying. So let's say the application server is actually a file server, because that's more easy to conceptualize in the modern day with everybody needing a file server too. And it should be a different physical box, if not VM, than the domain controller anyways. So this makes it kind of easier. So the request is first sent out, right, for the TGT. And if the domain controller is able to verify the credentials, then the user's workstation is the thing that actually receives the TGT. And then when you try to go to this service, so it actually needs the TGS, the ticket granting service, in order to decide if it has access to this application server. And this application server actually validates that ticket granting service on the back end with the domain controller. So that's why this communication is usually a thing over here, because the application server will almost certainly have to reach out to the domain controller to verify the user, which is kind of one of the interesting things in the Kerberos protocol, that not too many things do this out-of-band checking with another being to see if your credentials are verified or not. Usually it's just streamlined, right? Like in web, you generally just go to one box, that box goes back to another box and then comes back to you. But so this is a little different. So now that you got a ticket for, let's say, your file service, right? Your file server, the Kerberos application reply is going to come through, and that means that you definitely have access to those resources. So you can connect to the server beforehand, but let's say you need access to another share on that server. So that's another thing that this application request and reply is for. And that is then able to establish that you have access to this specific folder or share on that file server. So it's possible for a user, basically all these steps were kind of done for the concept of you can connect to the server as a guest, right, and not have anything, and not have access to anything on it. Or you might have access to one folder, but not this one. And if you need access to this one, you can put in a separate set of credentials to then authenticate yourself for this share. So that's kind of what a lot of this back and forth is doing. It's mostly just for flexibility of usability and the protocol itself. So within Kerberos, there's two special sort of tickets that you are able to produce if you have enough privileges. Golden tickets, which is a huge thing in like pen testing, if you're able to get your golden ticket, right? And it's kind of like Willy Wonka, right? You have access to the chocolate factory. Once you get the golden ticket, it's game over. So the forge granting ticket, since if you're able to forge this ticket, basically, since I don't really describe it here, you can basically use this ticket and say, yep, I have access to this. Don't worry about it. Yep, I have access to this. Don't worry about it. And that is because the golden ticket, let me make sure I didn't do this. So I didn't really go over this in the diagram, so I'll mention it here. So the golden ticket is actually derived from the password of the KRB GT user. So that's the user that actually has permissions to administer the KDC within Active Directory, which I know that's kind of like a jump within itself because it's never used for actual logon purposes. It just uses, Active Directory just uses that account to authenticate user credentials and user accesses. So it's hard to even, sometimes you can find it in the logs when it's doing real verification on the domain controller, but otherwise you'll almost never see that at all. And since it's forged, the Kerberos request and reply, the application request and reply doesn't take place. It's just like, okay, I know I have access to this, so you're granted. And these two problems are probably the biggest problems with Kerberos because who's heard of pass the ticket attacks? Okay, awesome. So pass the ticket attacks are really just, if you capture this ticket, right, you're then able to send this ticket from anywhere as if you own it. And from an authentication perspective, that's not great for obvious reasons, because then you can just say, yep, I'm this user. Yep, I have access to this application because I have this ticket, when you might not actually because you didn't go through the whole process to get the ticket. And that's a huge problem with the protocol itself that I won't really get into because I don't really like Kerberos, to be honest. So with the silver ticket, no traffic is ever sent to the KDC, and the scope is mostly limited to the specific service or application that you're trying to get access to. And it's worth noting that the golden and silver tickets are valid since they're derived from the password of that Kerberos service account, right? They're valid for basically infinity, right? Or there's a way to regenerate the tickets since they're derived from the user by resetting the password for that user. And funny enough, the only thing that does when you reset the password for that user is invalidate the current tickets that are in the wild. So it's kind of like a safe way. If you know you've probably been popped and somebody's generated a golden ticket, you're probably going to want to regenerate the password for that user, since that's the safest way to mitigate a golden ticket. Now, that doesn't mean they can't do it again. That just means the one they have currently is invalidated. So that doesn't mean like leave the malware on the domain controller. So as I mentioned with this, we're missing a whole step in this Kerberos process if we have a golden ticket. Since we have the golden ticket, we can just request access to this application, and eventually we're really just going to get access because it's trying to validate the ticket that is itself has access, which it does. So it's kind of an interesting part of the protocol. So the silver ticket actually skips the process to the domain controller entirely, and the application server is able to verify within itself or calling back to the domain controller that the silver ticket is valid. So with both of these totally bypass the entire authentication of the protocol, which you can just basically play over the wire as many times as you want. All right, so now we're going to get back to more of process level things. So services are a super important part of Windows. And this is what runs most of your system. Anything that the kernel doesn't start itself is usually embodied as a service that's a part of Windows. And most of these start either at boot time or when a certain event gets triggered and it starts. Like Windows Update usually has a trigger after a certain amount of time or a certain time that it starts and checks for updates. So these accounts generally run as a couple different service accounts right here. So we have trusted installer, local system, local service, and network service. So local system is pretty similar to the root account on Unix. And if anybody actually wants to use the local system account like in a command prompt to see what they can do, you can't do super much in Windows 10 actually. But if you look into the how to do sticky keys, how to get a command prompt from sticky keys on the login page, since that runs in session 0, like we've talked about earlier, which is system, that's the system session, your command prompt will actually say you are the system account. So if you ever want to play around with this stuff, you can go try that out, use the system account, and see what you can do. Services that are managed, services are usually managed with the SC command line tool, and this just uses the Windows APIs on the back end. You can't do the big things you can do with SC that you can't do through like the GUI is creating services, deleting services, and listing drivers. That's a pretty important one. So you can actually, drivers in Windows are kind of like services. At least that's how they're registered in the back end. And it's just a type of service. So the SC command line tool can actually let you list what drivers are running or registered to the system. And a lot of you that opened up even Task Manager and gone through your process list, you probably see a lot of SVC hosts, right? So the SVC host process was just a way for Microsoft to say, okay, we have this group of processes, or this group of, I don't want to say processes, but threads, really, that we need to all run at the same time because they depend on each other, right? So what they did is they made this svchost.exe that actually starts DLLs. And this can start a group of DLLs at a time for interdependent processes or interdependent applications to save resources on the system. So starting a thread is a lot less resource intensive than starting a thread is a lot less resource intensive than starting an entire process for each service that needs to be ran. So that's kind of why SVC hosts exists. It kind of collapses all of the resources required to a smaller process space. So services also have permissions, like the let's use the local service account as an example here. That doesn't have nearly as many as the permissions as the local system account, and that's mostly used for services that are just doing like one-off tasks or don't need to interact with the system, like creating too many files or anything like that. And that's mostly to just reduce that security scope down to less privileged processes. Because if you don't need the privilege, why would you give it to it? There's no point in that. So you can allow certain users to see or hide processes, but they'll still be running in the background regardless, and not if you can see them. And these are two of the commands that you can use to actually see and like set certain permissions on the services within SC. So drivers, like I mentioned previously, are like services. They're kind of registered to to Windows itself, Windows, the OS, the kernel, as a service. And usually, so this with Windows 10, they came out with user mode drivers, which are slightly different, but just for the sake of this, we're going to talk about the kernel variant, the more traditional drivers that run in kernel land. So generally what these drivers do is they're used to interface with hardware devices for your system. So that could go from your USB bus to your keyboard. So you'll need drivers to actually interface with those devices. That code all runs in the kernel space or the physical process space. They're not virtually mapped anywhere within memory. So there's device drivers, like we said, right? So this would be like a keyboard, mouse type of deal. Software drivers, which are mostly like networking stack drivers, are more of software drivers. So if you have to implement TCP, right? Microsoft implemented TCP in a driver, and that goes in their networking stack. That would be a software driver because there's no hardware device that interfaces with the TCP stack, right? Filter drivers are used mostly in the file system. So Windows Defender has a filter driver, another type of driver too, but so it can actually go, when you create a file, it actually gets a handle to the call that you use to create the file, so it can check over all that information as well. And that's one of the biggest ways that it catches like malware, right? It's got a hash database. It just does a signature check on what you're trying to write to the disk, and then it says, nope, I'm not going to let you write this to the disk. Access denied, and it quarantines it. So kernel land is much harder to develop in. You have a lot less live off the land type of situations. Actually, you can only live off the land, but it's mostly like starting from the ground up, live off the land. It's not like you're given nice shiny things. So this is gonna be funny. Minecraft, right? Who's played Minecraft? Everybody raise your hand. Yeah, there you go. There you go. So nobody starts with diamonds in Minecraft, right? That's otherworldly to start with diamonds. So developing in user land versus kernel land is kind of like starting with diamonds, right? You're given all the nice things up front, and then you just have to make your pickaxe from the diamonds, and that's fantastic. Then you can go wild. In kernel land, you got to go find those diamonds. You gotta find that iron. You gotta use that iron. Then you gotta hunt for those diamonds. That's what kernel land development's kind of like, folks. If you don't have to do it, you don't want to. Plus, in Windows 10 doesn't even let you run your own drivers by default, anyways, without doing special things. So if you ever want to make a driver, I discourage it. I almost immediately discourage it, unless you're doing it for like research. Research, if you wanna go make your own land, go to kernel land and try to make your own driver. But if you like starting with your diamonds, then just stay in user land, folks. So security implications that come with writing a driver. So there has been drivers that have had security vulns. A VirtualBox driver, Oracle, terrible, terrible company. VirtualBox back in the day, and back in the day meaning not that long ago, like 2013, 2015, they made a driver for VirtualBox. It needs drivers, it interfaces with the processor itself because it needs to do virtualization. They had a vuln in that. And so what you could do with the vuln in their driver is open it as really any user, right? And then you could just write to kernel space. Who loves to do that? You could literally just write another driver into kernel space and then start it. You could load a driver that you don't have access to do normally, like literally no access. Windows will not let you load anything that they haven't signed in kernel land. So this worked in Windows 10. Yeah, this is how important like writing drivers is. If there's any security vulns that can be exploited within your driver, that basically exploits anything you could possibly do in that system. Like you have full control. Like I'm not even talking system. It's basically one below system because you can get system on the command line. You can't really do much with that nowadays. They've kind of really isolated that user down to only specific use cases. But if you're in kernel land, man, you can do whatever you want. You basically are the system if you live in kernel land. You can do literally whatever you want. So yeah, we'll discuss this a little later in the application. Sorry, I went on a little rant there, but it's all fun and games. So programming in Windows. So with the nice user land, give us the diamonds up front approach, we get PowerShell, we get Batch. PowerShell, I prefer over Batch, but that's just me. C# is pretty good. If you're developing like user-based applications, C# is pretty good. Gives you a lot of space to do things. Really minimizes the code you have to write to do actual work, which is super nice. Visual Basic and VBScript, these have really taken a plunge in modern days for obvious reasons. C# is much nicer than Visual Basic and VBScript, and PowerShell is way nicer than VBScript. C and C++ are okay. They're still used. There's specific use cases that C# doesn't really get there for like performance, let's say. Performance is a big one, or for doing like low-ish level things. C and C++ is really the kings for that still. And as I was going through, there's pros and cons to each, right? PowerShell is super powerful, but some things might not actually be as fast as they will in Batch. Sorry. So that's something you got to kind of take in consideration if you're working on a project for Windows. So the .NET framework, so C# and PowerShell, they fully run off of the .NET framework. And if I was to like put the .NET framework, C# and PowerShell in like I guess a stack, right? So you have .NET, which is under everything. You have C#, which is kind of like in the middle, right? And then PowerShell, you can actually use PowerShell in C#. So that's even another abstraction on the .NET framework and on C# itself. So really what the .NET framework is a collection of APIs and libraries that you can use as a developer to just make things a lot easier for yourself if you're trying to develop an application that really does anything. And they provide a nice runtime environment, that allows you to not have to necessarily recompile your code for every different version of Windows, right? So that's super nice. So this runtime really abstracts your code to the system itself and is like, okay, so I know that this API way down here changed, so I don't want you to have to change your code that's way up there. And that makes a lot of sense to do from the developer's perspective. Exactly, PowerShell and C# interface with the .NET framework, and it's really easy to use, easy to understand, and really reduces the amount of code you have to write as a developer. So all in all, I'm a big fan of the .NET framework, and the Windows API is a little too dirty sometimes. So creating a process in C#, this is all you need. If you need to make a process for anything, executing a shell command, we're going to run hello world.exe right here. It's pretty simple. It's pretty simple. It's like 5 lines of code to start a process. That's really nice. C++, you need at least 25, 40 lines of code to do the same thing. So Windows API, this is what the .NET framework is built on, and this is the lowest level user mode API you can interact with. And this provides much more information, exactly, at the cost of effort. So it requires a lot more effort to create a process in C++ than it does in C#. So as you can see here, this is the doc for just the create process API you have to call, right? Some of these arguments you might not need, but even the doc of the parameters or the arguments for the function is longer than the C# code to use it. So that's kind of wild. How much code does it take to actually use this? A lot, because you have to set up all of these different structs. This is a really annoying struct to use. This is a really annoying struct to use. This is a really annoying struct to use. So it probably takes a good 5 to 10 lines of code just to initialize a couple of these structs, let alone actually create the process. So the native API is kind of like, let's leave it out in the shed, right? Because most of the time, you don't really want to deal with the Windows API, or the native API, sorry. So it's usually, so it's the hidden or secret API. That's because it's not documented. Windows only documents the APIs that they want developers to use, which makes sense from their point of view. And they kind of back that up by saying, well, the native API could really change at any point. And it could. So they give users a nice, stable interface to use to develop code upon. And exactly, they don't care if you use it, but they would prefer you not. Developers should be using the Windows API, and they don't document it, and it provides way too much information. So some of the information it provides, or you can even give it, this is even an abstraction on some of the native APIs. And this is documented really well. So it just depends on how much effort you want to go to use those APIs. So like this get thread information in the Windows API, so this is the Windows API. The thread memory priority and thread power throttling, those are the only two things you can really get from this in terms of the lowest level possible things. So the reason I say that is these values are actually taken into account at the scheduling level in the kernel, which is pretty low considering. And this is the native API version of this. And this basically allows you to do, it just has a lot more information. So this is one of the structs that you use. And you can just set a bunch of different stuff. This paragraph down here doesn't even say all the things you can do with it, which is kind of the point I'm trying to make here. So WMI is a very weird thing in Windows that not too many people know about, which is kind of why I wanted to cover it here. So it's actually it stands for Windows Management Instrumentation, and it's a very weird but extensive framework that serves as a management tool both for local boxes and remote boxes. So this can theoretically be accessed over the network to remote boxes as well. So the queries are pretty similar to SQL and database languages, which kind of makes sense because it's stored in a database somewhere, right? And you can actually list different groups or different objects, different entries in tables that exist within this database. So this is the kind of generic format of how to use the command. So you can actually use this WMI binary. That's a command line utility that you can use to interface with it. And I believe a lot of, if you've heard of COM objects is also a very lowly thing in Windows user land that allows for a lot of management techniques. But the credentials part up here is for remote systems or elevating privs usually. And you can actually create processes with a call to WMIC, which is kind of interesting. So from a security perspective, WMI events are pretty powerful, and they're basically like, you're basically telling the system that if something happens, right, I want you to execute this task. And that's pretty much how WMI events work. So that's pretty powerful. I'll have an example here in a second that demonstrates what you could use this for from a security or red team or even pen testing blue team perspective, or what you'd have to look for as blue team at least. So there's a couple of main requirements for creating an event within WMI. And so you need a filter, a consumer, and then you need to then bind the filter and consumer together. So filters are determined if an event can be triggered or not. So you can think about this like a filter in Wireshark, right? So you don't want to trigger on every single system event that happens, every single packet that goes through. You just want to look at TCP traffic. So you just want to look at a file being created instead of deletion, read, and all of that other file operations, all of those other file operations too. And so the consumer is what we would do with that information, right? So we can actually, if you're trying to create a file somewhere, we can actually do a post hook on that task and actually look into that file after you create it, which is kind of interesting. And the filter consumer bind is just the mechanism that holds them together and tells the system what to call if this happens. So in this example, we have a filter, a command that we want to run, the consumer, and then just the simple binding between the two. And this is all, you can all do this in PowerShell as well, and they make a nice like interface, nice command list for it to do in PowerShell. So for this filter, we just want to create a process, right? Or what are we doing here? The command is, we're making a text file at the C drive. And all we want to do is make that text file when somebody logs on. So, and this is kind of where this gets into a weird sense, because you'll need to know all of this SQL-like, this query information beforehand in order to formulate the query and put it where it needs to be. But then what happens is that this goes into the database for WMI, and the only way to really delete it, like who's looked at the WMI table entries? Like, it's not really fun to look through. It's kind of like the registry. It's another thing like the registry where a lot of powerful things happen in it, but it's kind of wishy-washy as to what it does and how to use it, since the registry is kind of just like a configuration database for a lot of different stuff. So a couple of specific security things that we won't go into too much depth, but I'll talk about it a little briefly. So UAC, right, that was added in Vista to kind of prevent malicious processes from hooking the elevated tokens that you could get as when you're elevating a process to administrator, right? So if you log into your box, everything's not going to be running as administrator by default, because that's a bad security practice. So what you want to do, you want to elevate things that you need to be at a higher level, security level, to administrator. And that's what UAC kind of did. But in XP, before Vista, malware could actually hook that and then retrieve that token that was then given to the new process that was administrator. So that was kind of prevented with UAC, with the secure desktop that we mentioned previously in the talk. Windows Resource Protection is another kind of interesting thing, and this kind of goes with kernel protections that I mentioned a little earlier. So with Windows 10, all of the drivers, right, have to be signed by first your cert, and then Microsoft needs to sign them. You need to verify them with them. And then an additional kernel protection, they've really done a lot to really protect their kernel land, is patch guard. I don't know if too many people have heard of that, but patch guard is really a process or a driver. It's sort of like a driver. It's really just part of the kernel that runs, and it does integrity validation of, let's say, like the process list of just important structures that are in the kernel. So it's kind of like a weird thing that's somewhat documented, but it's not said how they do it for obvious reasons, since it's like a mini antivirus that runs inside of kernel land and does validation on things. Because in Linux, right, if you make a rootkit for Linux, easy peasy, you can just remove processes from your task list, like from your process list. You just remove it entirely, and that's fine. You can totally do that. In Windows, it'll get really upset if you do that, and it'll actually blue screen with the error code bug check. So that error code specifically is one of the ones that PatchGuard sends, blue screens your box and sends to know that something was actually modified in kernel land. So I know we covered kind of a lot of information today, but does anybody have any questions? Yeah.
So one of the things we talked about when you were talking about Kerberos was the fact that golden tickets had like a 20-minute timeout on, right? Like before they would interact with the...
Go back to it.
No, can you just repeat it when you're going to answer?
I know what he's talking about. Oh, I'm sorry. I see what you're saying. My bad. So the question, sorry.
Yeah, so...
Good God.
So it has so the golden ticket has like a 20-minute timeout before it interacts with KBC, right? So does the silver ticket have that same problem, or not because it doesn't interact with KBC?
Okay, awesome. So on the slide with Kerberos, which I'll actually just go back to quick, because I know what you're mentioning, whether I can find it or not. There it is. KDC does not invalidate TGT, right? So the ticket granting ticket is actually the, it is not the golden ticket. So it is actually the first ticket the user would get on like login. And that's used to then get the ticket granting service, right? The ticket to grant the service. So that doesn't have like super much to do with the golden ticket, but the golden ticket kind of replaces the TGT in that sense, right? So that's kind of why that was there. And that's a great question because that was poorly explained. And sorry, the question, I missed it. I missed it. It's all done.
The question was about whether or not the silver ticket would do the same thing.
Right. So the question is whether the silver ticket would only be used after 20 minutes, I guess. So the silver ticket and the golden ticket, they're pretty similar. They both like kind of represent TGT or bypass that whole initial authentication point for the user. So I would say no. They are more similar than that. Yeah. All right. Awesome. Thanks, y'all.